Log into AWS Management Console and browse through VPC service. Click on Services tab. Scroll down. You can find the VPC service under Networking and Content Delivery section. Click on VPC. VPC dashboard will show you the resources which are currently created in this VPC service in the specified region. Click on your VPCs. You can see that there is one VPC already created in this region. AWS will ensure that there is one default VPC already created for every region so that it is quick to deploy the EC2 instances on the default VPC without you creating a VPC, subnet, route tables, and internet gateways. So far, the EC2 instances which I have created in the previous lectures are deployed into the default VPC. If you want to create a custom VPC with the custom network configurations based on the business need, you can still create a new VPC. To create a new custom VPC, click on Create VPC. Then specify the name of the VPC. Here I am mentioning the name as IVQ VPC. Then you need to specify the network range of the VPC. As discussed in the previous lecture, let me define the network range as 192.168.0.0/16. Then click on Create. So that AWS has created a VPC layer on this specified region. Click on Close. You can see that the VPC has got created successfally and the VPC has got allocated with the unique VPC ID and the subnet range. We can see that 192.168.0.0/16. Once the VPC has got created successfully, then you need to create a subnet. Click on Subnets. You can see that there are some subnets already got created which are called as a default subnets which are created in the default VPC. Since we are using the custom VPC, you need to create your own custom subnet as well for the custom VPC. Hence, to create a custom subnet, click on Create Subnet. Specify the subnet name. I will mention it as IVQ subnet 1. And we need to specify the VPC, in which VPC the subnet has to be get created. From the drop down, select the VPC which is just got created some time back. I am choosing IVQ VPC. Then you need to choose the subnet should be associated with which availability zone. From the drop down of the availability zones, we need to choose one of the availability zone. I am choosing US East 1A. One subnet can have only one availability zone, but one availability zone can have multiple subnets. And we need to specify network range of your subnet. As discussed, I am mentioning 192.168.1.0/24. The network range of your subnet should be within the range of your VPC. Then click on Create. So that the subnet has got created successfully and it has been allocated with one unique subnet ID. You can see that this subnet has the range of 192.168.1.0/24. That means there are 251 number of IPs are available in this subnet. When you go for a /24 CIDR block, you would be getting total 256 number of IPs. However, some IPs will be used for internal operations by the AWS. To get to know for what reasons the IP addresses are reserved by the AWS, let me go to Google and type AWS subnet IP reservation. When we look into this thread, it's clearly explaining that One IP address is used for the network identification, and one IP address is used by the VPC router in the backend, and one IP is reserved by the AWS, and one IP is reserved by the AWS for feature use, and one IP is used for the network broadcast purpose. That means for /24 network, there are 5 IPs which are reserved by the AWS for various reasons. Hence, out of total 256 number of IPs, 5 IPs are used by the AWS. Hence, only 251 number of IPs are made available for a customer use. Once the subnet is created successfully, then we need to create a route table. You can see that there is one route table already got created for your specific VPC, which is called as a main route table. The main route table is automatically get created by the AWS for your custom VPC. When you click on the routes, it has one entry stating that all the traffic should go through the local gateway if the destination is falling under the VPC range. If you want, you can use the main route table, or even you can create your own custom route table as well. Let me go ahead and create a new custom route table. To create a custom route table, click on Create Route Table. Then specify the name of the route table. I am specifying the name as IVQ route table 1. Then you need to specify this route table should be get created in which VPC. Select the VPC from the drop down. I am selecting the VPC as IVQ VPC. Then click on Create. The route table has successfully created, and the route table has associated with one route table ID, which is unique in this particular region. You can see that by default the custom route table which you have created has got one route entry, which is also stating that all the traffic should go through the local gateway if the destination is falling under the VPC range. You need to associate this route table to the subnets. Hence, go to the subnet association. Currently, there are no subnets associated with this route table. For the subnet association, click on Edit Subnet Associations and select the subnet from the drop-down. As I have only one subnet created so far in my VPC, I can see only one subnet is listed here. Select the subnet and click on Save. Now it will ensure that all the EC2 instances deployed in this custom subnet will be using this route table, and it will follow accordingly as per the routes defined here. So far I have created a VPC, subnet and the route table. When you deploy a EC2 instance in the subnet, the public IP should be get allocated automatically. Hence you need to do a small configuration changes for your subnet. Go back to the subnets, select the subnet which you have just created, go to Actions, and you can click on Modify Auto Assign IP Settings. Click on Enable Auto Assign Public IP and click on Save, so that the AWS will ensure that the public IP will be get allocated for the EC2 instances deployed in the subnet automatically. Since we have a VPC, subnet and route table, we are good to go ahead and deploy the EC2 instances in this VPC. To create a EC2 instances, head over to the EC2 service. From the EC2 dashboard, click on Instances. Currently, there are no instances created in this region. To create a new instance, click on Launch Instance. Then select the AMI of your choice. I am selecting Amazon Linux 2 AMI. Then select the instance type based on the business need. I am selecting T2.micro. Then in the step 3 configure instance details, we need to specify the number of instances. I'm going with one instance. And if you scroll down a little, you can see that there are some network components which needs to be selected. Under the network tab, you can see the drop down showing all the number of VPCs available in this region. Select the VPC in which VPC you would like to deploy this EC2 instance. Select the custom VPC which you have just created. Then automatically it will populate all the subnets which are created in this VPC. Since in this case there is only one subnet is created, it is showing only one subnet from the drop down. Select the subnet and go for next. Click on next, click on next, click on next. In the security group section, we can create a new security group, or we can even use the existing security group as well. If you want to select the existing security group, select an existing security group and choose the security group and click on review and launch. And click on launch. Choose the key pair. Then click on launch instances. Scroll down and click on view instances. AWS is now provisioning a new EC2 instance in the custom VPC. If you can observe the metadata of this EC2 instance, it has got allocated one private IP. The private IP is in the range of 192.168.1.0/24, which is the range of the subnet, which is also within the VPC range. And it has also got one public IP allocated automatically. The private IP is used to be connected within the VPC range, and the public IP is used to have access from the internet. In order to log into this EC2 instance, copy the public IP, go to the PuTTY, specify the IP, go to SSH, auth, browse, specify the key and click on open. If you can see that I am not able to establish a connection to the EC2 instance, as because the public IP is allocated for your EC2 instance, but the instance is not using the internet gateways. Hence, the EC2 instance doesn't have any internet connectivity to provide you the connectivity from outside of the AWS world. To get it fixed, you need to have a internet gateway attached for your VPC and update the route tables. Hence, go back to the AWS Management Console, click on Services, scroll down and click on VPC Service. In order to create an internet gateway, click on Internet Gateways. There is one internet gateway already available which is already attached with the default VPC. As we discussed, one VPC can have only one internet gateway. To create a new internet gateway, click on Create Internet Gateway. Specify the name of the internet gateway. I am specifying it as IVQ Internet Gateway. Then click on Create. Internet gateway is successfully created, but the internet gateway should be get attached for your VPC. Hence, select the internet gateway, click on Actions, Attach to VPC, then select the VPC from the drop-down. I am selecting IVQ VPC, then click on Attach. Now you can see that the internet gateway is successfully attached to your VPC, so that you can update your route tables accordingly to route the traffic to the internet gateway. Go back to the route tables. Click on the route table which you have just created and associated for the subnets. Click on routes. Click on edit routes. Click on add a route. Specify that by default the traffic should go through the internet gateway. In the target section, click on the drop down and select internet gateway and select the internet gateway which you have just created. Then click on save routes. Since the route table has a entry stating that by default the traffic should go through the internet gateway if the destination is not falling under the VPC range, this route table is called as a public route table, and the subnet which is associated with this route table is called as a public subnet. Now let me try to access the EC2 instance from outside of the AWS network. Go to the PuTTY, specify the public IP of the EC2 instance, click on Action, click on SSH, Auth, Browse, specify the key, open. We can see that now the server is accessible from outside of the AWS network. Click on Yes and then provide the username EC2-user. It is successfully authenticated and we are able to log into the Linux-based EC2 instances. This is covering how to create a VPC, subnet, route table and internet gateway, and you can deploy a EC2 instance on the